Okay, you should have your foldable called Special Angles in and on Circles. So this is actually going to be going onto page 102 of your notebook. If this is January 2025, if it's a different year, then maybe it's going on a different page. So make sure you read the directions. Okay, so when you have your foldable, you're going to notice that when you have it, you'll be able to cut that bottom piece off. So where the dashed line is, you're going to cut it straight across, because those are just some extra formulas that you're allowed to glue in your notebook on page 103, just so you have them. And then when you're left with the top half of the foldable, you will notice that the right and left hand sides fold in. So that way, on the outside of it, you'll see 1 and 2 and 7 and 8. And then on the inside of the foldable, you'll have 3 and 4 and 5 and 6. And you'll be able to look at my foldable in class if you're confused about how to fold it. So we're going to go ahead and start where it says central angles. So we have number 1, number 2 with central angles. Okay, so first thing, a central angle, you're going to want to put a note by this. A central angle, you see that central angle has the word center in it. So that means the vertex is the center. The vertex is the center of the circle. So when you're looking at a picture, right here is a vertex in the center of the circle. So this angle right here, this red one I'm tracing, you're going to want to make sure you have some colored pencils. This red one I'm tracing is a central angle because the vertex, the pointy V part, is in the center of the circle, the exact center. So whenever we have that, then you're going to want to highlight this or something. The measure of the arc is equal to the measure of the angle. So what that means when I look at this picture, which I just traced this one red, what that means is that this angle right here, that's 37 degrees, is going to be equal to its intercepted arc. They say intercepted arc because the angle would come out and intercept it and make this little arc right here. So that means if this inside is 37, then this outside is also 37 degrees. And that's going to be true only for central angles. Now, if we keep looking at the picture, we can see that we actually have another central angle there. So I'm going to get a new color. We have this angle right here. This is also a central angle because the vertex is in the center of the circle. So since this is 41 here, then we know the intercepted arc out here is also 41. Did I say 47? 41 degrees. So we have a 37 and a 41 degrees. Sorry about my writing. 41 degrees. Okay, so let's see what this picture has. Now, we're going to actually be able to apply a bunch of other stuff that we've already learned about. Like if we look at this picture, can you see that we have an X right here? See the pink X? And we remember angles on opposite sides of the X are going to be congruent because they're vertical angles. So if this over here is 41, then this one over here is also 41. And since the vertex is in the center, we know this intercepted arc out here is also 41. You see how we can keep building on things we know? Now we also know some stuff about half circles, right? So if I take this half a circle right here, that means that all of this stuff up here has to be adding up to 180, right? So I have a 37, I have a 41, and I need to figure out what number is going to have to add to it to make 180 degrees. And if you get out your calculator, what's 37 plus 41? And then subtract that. What am I going to get? 102. So this angle, here's 102, and this arc out here is 102. And these are all degrees, right? Now, we also can use other things. Like we could say, hey, you know what? I have another half a circle down here. So I have a 41, so I could figure out what this is down here. Or I could use the idea of 360 all the way around a circle. Whatever math I want to use. Let's go ahead and do the 180 again. So this is 180 total. So I have the 41 right here, which I kind of went over. Can't see it. What is 180 minus 41? What do I get down there? 180 minus 40, 139. So that's 139 degrees out here and 139 degrees in here. And I can go ahead and check my math. If I add all these up in here, I should get 360. If I add up all the numbers around the circle, all of these arcs out here, I should also get 360. Okay, so let's see what they actually ask us to do. Now, sometimes we don't need to do all this stuff. We're just being extra because it's our notes. So let's see what they want us to do. They want us to find us arc DE. So they want us to find the measure of DE. Remember, that's a minor arc. It's just 2 letters. So that means it's a small one, less than 180 degrees. So from D to E is right here. From D to E in my picture, I know I kind of wrote all over everything, is 37 degrees. So D to E is 37 degrees. Okay, the other thing they want us to find, I should go ahead and write that over here. The measure of arc DE equals 37 degrees. Okay, then we also want to know the measure of arc DCA. Now that's a major arc, so that's going to be 180 or more. I have to go from D to C to A. So that's where's D? That's D to C to A. So we need to add up everything from D to C all the way over to A. Now I'm going to go from D to C is 102, right? 102. Okay, and then we're going to go from C to B to A. So that's plus 41 plus from there to there, that's 139. So if I add all of those together, 102 plus 41 plus 139, what do I get? 282. Double check with your calculator. Okay. Make sure you have different colors. You could add extra notes. Remember, you don't need to always get all of these numbers. We're just being extra. Okay, let's check out the second one. So we're going to find the measure of each arc. So in this picture, I see all these different arcs. So I'm going to find all of them. So I do have this 42. Now you have to ask yourself, is that a central angle? So in other words, is the vertex in the center? If it is, then the 42 out here is the same as the 42 out here. Okay. Now what else can we use? We have a couple options. We can look for half circles. We could look for whole circles. We could also look for old things like linear pairs and vertical angles, because remember, those are all same things in the same pie. So I'm going to go ahead and do vertical angles, because I always like to look for the X, right? So if 42 is on this side, then I know 42 is over here, right? And that's also a central angle, so I know 42 is out here. This little arc out here is also 42 degrees. These are all degrees, obviously. Okay, now we need to get the other pieces, and I'm going to use the idea of linear pairs or half circles. So if I look at, this is a linear pair, right? From here to here, that's a half of a pizza or a halfway around a circle. That's going to be a total of 180 degrees. So if this part's 42, what do you have to add to 42 to get to 180? That's going to be 138. And so this inside is 138. And then you could use the whole idea. You could still use this X, vertical angles, one side to the other. So if it's 138 here, we have vertical angles. And so that's 138 on the other side. And that makes this arc out here 138, because these are all central angles because the vertex is in the center. Remember, if the vertex is not in the center, then you cannot use central angles. Okay, let's see what they want us to find out. RS. That is a minor arc, just from R to S. So from R to S, it looks like that is 138. B, we need to go from Q to R to S. So where's Q? Q is here, to R to S. So Q to R to S looks like that is a half circle, so that's going to be 180 degrees. Next one, we've got Q to S to T. So Q, that's here, to S, all the way around, to T. So that is going to be a half a circle, so that's going to be 180, right? Plus, so Q to S to T. So 180 plus 42. What do we get? 180 plus 42. That's 222 degrees. Okay, now what's the last one we have? Q to T. So let's look just from Q over to T. Q to T is only 138 degrees. Okay, cool. Make sure you have all kinds of notes around here, whatever you need. Remember, this is going to be glued in your notebook, so you might have some space around your notebook too if you wanted to add extra notes. Okay, we're going to go inside the foldable now. So we did number 1 and number 2. Let's go ahead and go to the inside. We're going to skip 7 and 8 first. So we're going to go to the inside, and we're going to do numbers 3, 4, 5, 6. Okay, so this is number 3 right here. Okay, so let's look what we have a little note at the top here. So the little note on the top says, inscribed angles, the vertex is on the circle. So highlight that, get a bright color, something. The vertex is on the circle. So it's not in the middle anymore. Remember, central was the center. Easy to remember. Inscribed is on the circle. So find some way to memorize it. Inscribed is on the circle. And they're not going to be equal anymore. They actually do have a relationship. So there is a theorem that says the measure of an inscribed angle is 1/2 the measure of its intercepted arc, which means the arc is bigger, twice as big. So the arc is bigger. Make sure you remember that. The arc is bigger, 2 times as big. If you know the arc, you can cut it in half to get the angle. If you know the angle, you can double it to get the arc, because they have that relationship of one's half as big as the other, which means the other one's double as big as the other. Okay, so let's go ahead and look at this picture. This is number 3. So these are inscribed angles because the vertex is on the circle. On the circle. So you see this B right here? This is on the circle, correct? On the circle. So if I talk about this blue angle, get a color him blue, because this picture has more than one angle. So let's talk about the blue guy right now. That's it. So it says that this angle has a special relationship with its intercepted arc. They say intercepted arc because you can see how it cuts it, right? So I'm going to go ahead and draw this blue. And I always think that these look like ice cream cones. Well, this looks like an upside down ice cream cone. Kind of lopsided, but still. It's still like an ice cream cone to me. So I always know that the big fat arc, the big fat ice cream, is twice as big as the bottom of the cone. Obviously, think about a cone. Isn't the bottom in your head? Think of it smaller than the top of the cone. This guy's upside down, but it doesn't matter. So if this is 45, he's inscribed, so that means this side is twice as big, bigger. So he's going to be twice as big as 45. So 45 times 2 gives you 90. So this arc out here is 90 degrees. So basically you're saying this is 90 degrees. Like all the way around is 360. This is 90 of it. So about 1/4 of the way around. That looks legit, right? Okay, so that's cool. That's one arc taken care of. Now let's get a new color because we have another. I'll go orange. Okay, so you see this angle, the orange guy, you have a new color? He also has a vertex on the circle, right? You see vertex D right on the circle. You see this ice cream cone? Yummy, delicious. This bottom part of the ice cream cone is half the size of the intercepted arc. So in this case, the intercepted arc is right here. It's 76. So what we have to do is go smaller, right? So this is going to be half the size. Where this one was times 2, right? Okay, so we need half of 76 to go right in here. So you need 76 cut in half. What do we get? 76 in half is 38 degrees. Okie dokie. So remember, think of your ice cream cone. The bottom skinny part of your ice cream cone is half the size of the big fat ice cream part. So take your skinny part and double it to get the fat part. Take your skinny part, double it to get the fat part. Cool? Okay, we're going to go down. This is number 4 in your foldable. Okay, so this has some angles. Now, first thing, are there any central angles in this picture? Central means the vertex would be in the center. So the center looks like about right there. Are there any angles whose vertex is the center? No, there are no central angles, right? No central angles. No central angles, which means none of them are going to be equal. Remember the first couple ones we did, these ones were all equal, 37 and 37, 41 and 41, because they had the vertex in the center. All of these in this picture don't have any central angles. There's no vertex in the center. So we're dealing with inscribed angles, because inscribed means what? Inscribed means the vertex is on the circle. On the circle. Okay, so we do have a bunch of them in this picture, right? So let's look at this guy right here. He has a vertex on the circle. So I'm going to take blue, I'm going to trace him because I have a 31 in there. So I'm going to start with this guy. Okay, do you see the ice cream cone? Okay, here's the ice cream. Yummy. Top of the cone. Okay, so the ice cream cone is small on the bottom, 31. What do I have to do to get the outside out here? It's got to be times 2, right? It's got to be bigger. Times 2. So 31 times 2. What is 31 times 2? Equals 62 degrees out there. 62 degrees. Okie dokie. Now, can I get anything else from this picture? I don't have any information around here. I don't have any half circles because, oh wait, I do have a half circle. Wait, no, this didn't go through the very center. We're not sure if this actually hits the center or not. It looks like the center might be a little bit above this. So we don't really have anything going through the center that we know for sure. But there's another angle that sometimes people don't see. This right here is a central angle, right? I'm sorry, an inscribed angle because the vertex is on the circle. Now watch when I make this ice cream cone. What's true about the ice cream? The ice cream, you see it? This ice cream is the exact same as the other ice cream because they both cross at S and T. So do you see how this blue ice cream out here is the same as this red ice cream out here? And that means I could just look at this red one and I know that this out here is also 62. The red guy is 62, right? And that means I can go inside. Now, do I have to double it or cut it in half to get to the skinny little cone part? I'm going to have to cut 62 in half to get to the skinny little cone, right? And 62 in half is also going to be 31 degrees. So these are both going to be 31 degrees. And I really can't get anything else in this picture because I don't know if anything goes through the actual center, so I can't really use half circles or anything. So that's all we're going to do for that one right now. Okay, let's go to number 5. This one's got a lot of stuff going on. Now, we do have something that goes through the center, right? The center is this U. I'm sorry. We don't have any angles coming out of it because there's no vertex at the center, so we don't have any central angles. But we do have a lot of inscribed angles, and we might be able to get half circles too, right? Okay, so let's use the two pieces of information that they gave us. So we're going to start off with 2 colors, even though we're going to be able to get a lot more after that. Okay, so let's start with this L. You see how this is a inscribed angle? And it wraps around this 68. Do you see how he's a big fat ice cream cone? And here's my ice cream. Okay, so this is my ice cream cone. So this is 68. So is this ice cream going to be 68 also? Or is it going to be half as big or twice as big or what? Now remember, the cone is the half part, right? The skinny part. So that means this ice cream has to be twice as big as 68. So the ice cream has to be 68 times 2. What's 68 times 2? 136. And that makes sense because remember, a halfway around the circle is 180. So this has got to be pretty big, right? Because we're almost going halfway. You know what? And since we just talked about that, why don't we just do that halfway? I'm going to get a highlighter right here. I'm going to draw this halfway mark. Because I know on this side, if I go halfway around, 136 plus something is going to have to equal up to 180, right? So this half circle out here, it's going to be 180, right? So 180 minus 136. What do I get there? 180 minus 136. I get 44. So I can get this piece right here is 44 degrees. Might as well get that, right? Okay, where do you want to go now? Do you want to use the 92 or do you want to use the 44? I'm going to go ahead and use the 44 because 44 is this arc right here, right? And he also has, he's the ice cream on top of this cone right here. You see the vertex on the circle, inscribed angle. Do you see this pink skinny ice cream cone? That's the inscribed angle. So if we know the ice cream is 44, the ice cream is the big fat top, right? So how much is this little skinny bottom way down in here? Has to be half the size of 44. What's 44 in half? Is 22 degrees. So this crack right down here is 22 degrees. Okay, what else can we get? Want to go do the 92? Okay, so 92 is out here. That's this arc, right? So that is your green ice cream, right? Now, do you see the cone? Remember, the cone has to be an inscribed angle, so the point of the cone has to be on the circle. So you got to come all the way over to here on the circle. Do you see my ice cream cone? Now remember, you can't get an ice cream cone with, like this can't be the point of the ice cream cone because this is not on the circle. So remember, even though you might be like, oh, there's a little ice cream cone here, you can't use it because it's got to go all the way to the, on the circle. Okay, so you see my little ice cream cone. So this is 92. I got to come all the way in here. Now, is it going to be twice as big or half as big? What's bigger? The ice cream is the big fat part and the cone is the little skinny part, right? So cut this baby in half. So you need to do 92 divided by 2 to get that little piece, this angle in here. What's 92 divided by 2? 46. Okay, is our picture too crazy yet? Because we can still get more. I challenge you. Can you get this piece out here? Here's your clue. This is a half a circle, right? So this whole thing is 180. You know the green part, right? So can you get the orange part? Okay, go ahead and get the orange part. because after you get the orange part, you'll be able to get this orange ice cream cone, right? See the orange ice cream cone? So if you knew this part out here, couldn't you work your way in and get this angle down in here? Because you know he's going to be half as big. Okay, now I understand our picture is going to be full of stuff, but you can actually get all of these angles here. So go ahead and try to get all the angles, because if you have some triangles, do you see this triangle right here? I will shade this triangle blue. Do you see this triangle right here? We already have the 22 and we have the 46, so we can get this last angle right in here because they have to add it to be 180 inside every triangle. And once you get that one, you can get the one across from it for vertical angles, right? You can get the one next to it because of either linear pair, or maybe you might want to use this white triangle over here after you got that one. There's also a little baby triangle over here that you can get all of the angles of that, because you also have a weird ice cream cone over here. So you can actually get every single angle and every single arc in this picture, but it's too small for me to do on this little screen. So you try to get all the other ones also. Okay, let's go down to number 6. Okay, this is number 6. Okay, so that's a theta. Theta means that's an angle that we're going to try to find. It's just like a variable for an angle measure. We have a 25 right here, so I'm going to go ahead and start with that 25. He's kind of small, but he does have a vertex on the circle, so I do know that he's an inscribed angle, and that means I got my ice cream out here. If this is 25, that's the skinny part of the cone. The ice cream part is twice as big, so the ice cream out here is going to be 50 degrees. Now, don't look at this as a half a circle here, right? Because this doesn't go through the center, but you can use this half a circle later on if we need to. Which actually, let's go ahead and do that. Because I have this half a circle right here, right? If I knew this 50, boom, 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 I could figure out the rest of it, right? Because this is a half a circle, so 50, what's this rest of this have to be? 50 plus what makes 180? So we've got 130 over here. Okay, what else do we want to get? We want to know this theta, right? So this theta, can actually get that theta right now because that's our ice cream on that theta, isn't it? So to get this angle, that's an inscribed angle. This is 130. What do we have to do here to get this? Do we do 130 again? Do we cut it in half? Do we double it? What do we do for the little skinny part of the cone? We divide by 2 and we get 65 degrees. We didn't even need this 80 over here. We could have used this 80 though. Look, this 80. Do you see how he's the top of the ice cream of this guy? You see that ice cream cone? So we can do this 80 in here. The little cone part, the ice cream is twice as big. Thank God, because I love ice cream. 80, this is 40 degrees in here. We can get some other stuff too. We could work on some triangles. We can get more information, but really we are just looking for the measure of theta. And so that was 65 degrees. Okay, let's go back to the right-hand flap to number 7 and 8. Okay, so we have some inscribed quadrilaterals. What's quadrilateral? That has 4 sides. Inscribed means all the vertices are on it. All vertices on circle. So you see how boom, 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 boom. All 4 of them have to be on the circle. So you might want to put a little note somewhere on your paper so that you remember, or maybe you just want to make them bright and pink like that. All four of them. All four. All four. Okay, and there's something that's true about them. There is a theorem that says that opposite angles are supplementary. So that means the angles that are diagonal across from each other. So this y and this 120 are supplementary. The y and the 120 are supplementary. So that means the y plus the 120 have to equal 180, because that's what supplementary means, right? So if the y plus the 120 has to equal 180, what does y have to equal? Well, you could probably do that in your head. I mean, you could get all technical and do minus 120 on both sides, or you could just subtract in your head and figure out that y is going to be 60. Okay, we also have another pair of opposite angles. So opposite angles. These two are also opposite. So that means z plus 80 also has to equal 180. So we could figure out what z is, and that one you could probably do in your head, subtracting 80 from that, so you get z is equal to 100. All right, let's go ahead and check out the next one. Okay, this one's got a little bit more going on. So it looks like we do have a inscribed. So let's go ahead and put, we have an inscribed quadrilateral, which means that the angles across from each other are going to be supplementary, right? So that means that the 93 plus that z have to equal 180. So what is 93 plus z? What's that have to be then? Put that in your calculator. What do we get when we do 180 minus, we get 87. So we get z is equal 87, equal to 87. So I'm going to put 87 right in this spot right here. Okay, now we can also go the other way. We do know that the y plus the x also have to be supplementary, but we don't know either of them right this minute, so we can't really get either one. But we do have some information around the side. So I would say if we have any central angles or inscribed angles, that's the ice cream cone, wraps around those. So let's see what we have here. So if we try to figure out what x is, let's see where that is. Let's get a color. This x angle, that is an inscribed angle. So that's from here to there, right? So do you see where the ice cream is? The ice cream is from all the way around here. This whole purple ice cream. Purple ice cream, yum. Okay, so if we knew how much this purple ice cream was, we could figure out what that angle is, right? Because that is a big fat ice cream cone. And we have some numbers out here. So we have this 58 and this 106. So that is the purple ice cream, right? So the 106 plus the 58, what do we get? 106 plus 58 is 164. So the ice cream out here is 164. Remember, halfway around a circle is 180, so this looks like a perfectly fine number, right? So this is 164. So that means to come inside here all the way across, that's our inscribed angle. And remember, the cone is half the size of the ice cream, so we're going to have to take this number and divide it by 2. 164 divided by 2 is 82. So this is 82 right here. 82 degrees. And now that we know the 82 degrees, we could figure out this, because these two orange ones that I have this little orange thing, these two guys were supplementary. So we have this 82 degrees down here plus this y has to equal 180 degrees. So we can solve in our head, or we can subtract 82 from both sides doing some algebra, and we get y is equal to, what is that, 98? So y is 98. So we've got all of our parts now, 98. And remember, inside a quadrilateral should be 360 degrees too. So we could always check by doing 82 plus 87 plus 98 plus 93 and see if we get 360. Because remember, triangles are 180 and quadrilaterals are 360, so we could check it that way. Oh gosh. Okay, so remember the bottom of this foldable is cut off and glued on a separate page, and then this foldable is going to be glued in your notebook.